video. So section 2.2, vertex form of a quadratic. We're going to review the vertex form, which we already introduced yesterday, and maybe just go into a little bit more detail about some of the characteristics. Okay. So the next thing you want to do is write out the vertex form, which you already know. It's the same vertex form I put up on the board during homework questions. F of x equals a times the quantity x minus h squared plus k. If you haven't done this yesterday, or you don't know it today, you can add that a is responsible for stretch, shrinks, and reflections. H is responsible for moving your graph left and right. And K is responsible for moving your graph up and down. Some of you are probably to the point where like, yes, I already know that. And then others of us are saying, maybe I should write this down. So it's up to you how you feel about that. I'm going to give you two pieces of information today. Vertex, axis of symmetry. We defined vertex yesterday as like the minimum or the maximum point of your parabola. It depended on the orientation, whether your parabola opened up or whether your parabola opened down. And we've kind of already talked about the vertex in a couple of scenarios, but let's look at the vertex form with A, H, and K. Two of those are the coordinates of the vertex, A, H, or K. Which of the two represent your vertex? Kyle? H and K. So we're going to write that if we're working in vertex form, our vertex is always HK. Every single time you can quickly identify the vertex by pulling out the H and the K from the equation. Now, H is a little bit tricky. Remember that because in the vertex form it says minus H, when you put positive numbers in, they look like negative numbers. Or if I put a negative number in for H, then it becomes minus a negative, so it looks like plus. So always note that H looks like the opposite. If you see x plus 3, it's actually, when you pull H out, it's actually a negative 3. If you see x minus 2, when you pull H out, it's actually a positive 2. Okay. K does not have that problem. It looks like what it is because it has a addition sign in front of it. You guys all took geometry last year, so I'm curious if you could give me a definition for an axis of symmetry based on your knowledge from geometry. What do you think an axis of symmetry could be? Jackson? A line of symmetry, and can you tell me what the line of symmetry would be? You split it in. Okay, so it's a line that, and can I say splits the parabola, because we're talking about quadratics? A line that splits the parabola in half. So both sides are equal. Both sides are symmetrical. They look the same. It's a line of reflection, so that if I fold on that line, one side of my graph will reflect onto the other side of my graph. The only thing I'm going to add to that definition is a little piece that says our axis of symmetry for a parabola must go through the vertex point. It has to. It's the only place the line of symmetry can go. So I'm going to say must go through the vertex. And I'll draw a picture. Here's a parabola. There's its vertex. The only place I can draw a line of symmetry is a vertical line through the vertex, so that the two arms of the parabola fold onto each other. So my axis of symmetry, I'll draw as a dotted line right here, goes through the vertex, required. Because the axis of symmetry always goes through the vertex, it's really easy to write the equation for the axis of symmetry, which, remember, the axis of symmetry, like Jackson said, is just a line. So it's always a vertical line, and vertical lines always have the equation x equals a number. Ours is going to be x equals h. It's the same h that you got in the vertex. So like if it looks like x plus 3 and you pull it out of the equation and it's a negative 3 in the vertex, then in the axis of symmetry it's x equals negative 3. Okay? It's the same exact value that you have in your vertex for h. Now I'm going to challenge you as Algebra 2 students, when I ask for an axis of symmetry, don't just give me a number. Don't tell me the axis of symmetry is 1. 1 what? 1 an x-coordinate, a y-coordinate, a horizontal line, a vertical line, I don't know. Tell me x equals 1, a vertical line. Okay, so I challenge you with that to get that piece. Let's look at an example. We're going to do this function, f of x equals negative 2 times the quantity x plus 3 squared plus 4. And we're going to do two things. We're going to label its vertex. We're going to label its axis of symmetry. Sometimes when people are starting out, they have trouble deciding, like in that equation, which numbers are which letters for A, H, and K. So one thing that I encourage people to do if you're struggling is write the vertex form either above or below the equation. So f of x equals a times x minus h squared plus k. And this will help you because if you're trying to find the vertex, you know the vertex is located at hk. You now know which numbers represent h and k. So I want to pull out my vertex. What's my h value if it looks like x plus 3? Must be negative 3, thank you. And my k value looks like what it really is, so my k value is 4. So I have a vertex at negative 3, 4. My axis of symmetry is x equals negative 3. X equals h. I'm done. This is a skill we'll use over and over in different functions throughout the year. So the better you're able to identify the h and the k, the more helpful it will be going forward. Okay, not all graphs will have the axis of symmetry, but the parabola will because it's symmetrical. Okay. I'm going to put up two problems on the board, and you can write them down in your notebook if you like, but what I'd really like for you to do is take a minute to talk it over with your partner and see if you agree on what the vertex and the axis of symmetry is. So on the next slide, we want to identify the vertex and the axis of symmetry for these two functions. So go ahead, take a minute to talk it over with your partner and see if you guys can come up with some answers. And then let's talk about what we got for our vertex and axis of symmetry. So, Agat, did you guys get a vertex for the first one, f of x? Did you get any part of the vertex? You got the second one, but not the first one? Okay, so I'll come back to you for the second one. Jace, do you have a vertex for the first one, f of x?
Yeah.
What'd you say? Negative 1, 0. Okay, so think about that. If we write the vertex form right above this, f of x equals a times the quantity x minus h squared plus k, we'd be looking for our h, which it looks like plus 1, so when we take it out, it's actually a negative 1. And the big question that comes up is, what's k if there's nothing there? Okay. So think about it. You're usually adding k. What's a good way to add nothing? Plus 0, right? A lot of times people will say, well, it's either a 1 or a 0, because sometimes in math we'll put a 1 where there's nothing. Like if it's 2x plus x, there's really a 1 in front of the x. So people will say, well, it's either 0 or 1. But in this case, it actually would be 0, because if it was plus 1, we'd see plus 1, right? Okay, so it must be 0 right there, which gives us a vertex of negative 1, 0, which is on the x-axis. Stephen, did you guys get AOS?
I think we were just there would no be negative 1. Then I spelled it out.
What am I waiting for? X equals, right? We want to challenge ourselves. When we label the axis of symmetry, we want to call it an equation of the line. But it's just always h. And I had a great question as I was going around. Is this h also looking like the opposite? Absolutely. Okay. So whatever the first part of your vertex is, that is always the number for the axis of symmetry. They never change. They're always the same. So they always match. Okay, okay. Did you have the second vertex? Negative 2, 5? Is that what you said? Close. Positive 2, 5. Why is it positive 2? You can tell us why it's positive 2, 5. Kylie? H is the one that looks like the opposite, because when you put it into the vertex form, remember it's x minus h. So if I put in a positive, then it looks like x minus 2. So it must have been a positive 2 when I pull it back out. H always looks like the opposite. And then our AOS for this one is x equals 2. You don't have to do any work for axis of symmetry if you've already done your vertex. It's just the h coordinate of the vertex. Any questions on those two examples that I can clarify for you now? Okay, one last thing that we want to talk about are maximums and minimums, and then increasing and decreasing intervals. Okay, so this is the last thing, then we'll do an example, and then I'll give you your homework assignment for today. So min and max we actually mentioned yesterday. Okay. A parabola can either have a minimum or a maximum. It can't have both. It depends on the orientation of the parabola. And what's the name for the special point that is the minimum or the maximum? It's always the vertex, okay? So if we have a parabola that opens up, then our vertex is a minimum. If I have a parabola that opens down, then my vertex becomes a maximum. How will I know, looking at an equation, if I have a parabola that opens up or a parabola that opens down? By the value of a. If you have a positive a, then you're going to have a minimum value because the graph will be oriented so that it opens up. If you have a negative a, so if your function starts with a negative, then you'll automatically have a maximum, and it will open down. Now, increasing and decreasing intervals, every parabola consists of one increasing and one decreasing interval. And that is always split by your vertex or axis of symmetry. When we talk about increasing and decreasing intervals, it's important that we read graphs the same way we read sentences, from left to right. If you're having a hard time looking at a graph and deciding it's increasing or decreasing, I suggest putting your finger or your pen or your pencil on the left side of your graph and then just tracing and deciding where is my graph increasing, my finger is going up, where is my graph decreasing, where my finger is going down. So for example, I could have a parabola like this. Here's my vertex. Here's my axis of symmetry. I'm increasing on the right side of the parabola, and I'm decreasing on the left side of the parabola. If I turn that so that I have a maximum, the increasing and decreasing will switch sides. I'll be increasing on the left and decreasing on the right. So we're going to look at an example. How do we find minimum and maximum points and identify them? And then can we also figure out our increasing or decreasing intervals? Okay, so our first example here, we're going to do f of x equals negative x plus 1 squared minus 3. So that's the function that we're working with. If you like to, write vertex form right underneath that with the a, h, and k. Okay, so first thing we want to find is a minimum or a maximum. I'm going to ask you this question. Will this graph have a minimum or a maximum? And why? Faith, you say? Maximum because? Because at the very front of the function it says negative. So that automatically means that this graph is opening down. So I will have a maximum value. If there was no negative, then we could automatically assume it was a minimum. So where is the maximum? If you look back at our notes, the min and the max are represented by the vertex. So all we have to do to identify the maximum is pick out the vertex. What's the vertex of this function? Negative 1, negative 3. If you're trying to visualize that in your head, you'd go left 1, down 3. There's a point. We know that it opens down. So we have a maximum. We have a parabola that opens down. That's using my transformations from the previous section. Let's do domain and range, which here it's really good that we did domain and range in our homework. What's the domain for all quadratics? All real numbers. So I'm going to say x equals all real numbers. What about the range for this function? Can I go everywhere up and down? No, I'm limited, right? And because I have a maximum, what's the highest point I can get to on the y's?
-1.
I can get all the way up to -1?
Oh. -3.
-3. Make sure you use your k value for range, right? Because k is like your y. And it's everything less than that. So it's less than or equal to -3. So I have domain and range. And the last thing we want to do is identify increasing and decreasing. And this is where we're actually going to use like our vertex, or more specifically our axis of symmetry, to split the graph. So you can imagine your axis of symmetry right here going through the vertex, and this is x equals -1. On the left side of the graph, for all the numbers that are less than -1, is my graph increasing or decreasing right there, from left to right? Increasing. So it's increasing when x is less than -1. When it's -2, when it's -3, when it's -4, always the graph is increasing. Then, at -1, it turns around, and after that, it starts to decrease. So for the decreasing interval, we can say for all x's greater than -1. Now, notice that my increasing and decreasing intervals leave off the or equals to piece. Okay, so when we talk about intervals on which we increase and decrease, we don't include the -1 because we can't really say if it's increasing or decreasing at that point. It's represented by a maximum value. So we don't want to include it in either set. It's its own special point as a maximum, and the points after it will be our increasing or decreasing function. Any questions about those 5 things we did that I can clarify for you? Okay, so that's it for our note.